Let's continue with L'Hopital's rule. Remember that L'Hopital's rule says if we have indeterminate form, limit as x approaches a over f of x over g of x gives 0 over 0 or I guess I'll say plus or minus infinity over infinity, then the limit as x approaches a of f of x over g of x equals the limit as x approaches a of f prime of x over g prime of x. Okay? So anyway, let's look at example 6, right? Let's model BAC by this function. So let's take a look, right? So what do I say? Find the limit as I don't know why I say n approaches infinity. Sorry, that should be a t. T approaches infinity, and explain what it represents, like what's going on here. All right. So the limit as I guess I should say is t approaches infinity of c of t equals the limit as t approaches infinity of this guy. Okay? And at this point, if we take the limit, well, actually, maybe we could do even one more thing before we take the limit, because negative exponents can be a little tricky. So just remember that we have this. E to the negative exponent is 1 over e to the positive, right? So we really have this. I think that's much nicer to look at. And here I hope you can see that we do, in fact, have a fraction. And even though 0.0225 is a small number, as t gets large, that will get large. And this, again, even though the power has a small coefficient, will also get large as t gets large. So we do, in fact, have infinity over infinity. So we do get to use L'Hopital's rule, take the derivative. And this works out pretty nicely, right? 0.0025 over, and this is going to be 0.0467 e to the 0.0467 t, right? Chain rule. Right, to be clear, that is t. Okay. And at this point, we can take the limit. And we're just going to get 0.0025 all over. Well, actually, it's going to be over a big number. So actually, I think we can erase this. We have a constant over a number that gets bigger and bigger. Slowly, but it gets bigger and bigger. So this winds up being 0. Let me actually stick it over here. Now, what does this limit mean? What does this limit mean? I want you to write a sentence about what it means, and I want to ask you about it in class. Okay? So try it. Write a sentence right there. Anyway, suppose we have a situation where we have differences. Okay? Now, I claim this is the L'Hopital's rule problem. May not look it, but it is an indeterminate form problem. Not sure how obvious it is, but it looks pretty gross. Right? It's one of these infinity minus infinity problems. And the way that you do this is you have to combine the fraction, common denominator, and then we're going to use L'Hopital's rule. Right? So if we do this trick, right, we get x times ln of x minus 1 times x minus 1 all over the common denominator, x minus 1 ln of x. Okay? And at this point, we actually can use L'Hopital's rule, because if you notice, if you plug in 1, ln of 1 goes to 0, and then we have this goes to 0 too. This is 0, and that's 0 also. So all sorts of 0 over zeros. And so we use L'Hopital's rule. Limit x goes to 1. Now, we do have a product rule here, but it's not the end of the world. That's not that bad a product rule. right? And just to be clear, this derivative is this, okay? And that derivative is that, okay? And then we have another product rule over here. Right? This derivative is this. Okay? So anyway, we do it, right? We just kind of simplify some stuff out here, and I think it's going to work out a little bit nicer, right? Because these guys just cancel. Do we see that? Cancel, cancel. And we're left with ln of x all over ln of x plus x minus 1 over x. Okay? Unfortunately, if we take this limit, we once again get 0 over 0. Oh, this problem is frustrating, right? Never seems to end. Let's use L'Hopital's rule again. I don't think it's actually that frustrating. I think it's a cool problem, right? Anyway, we get 1 over x divided by 1 over x plus, and then if you do the quotient rule, I think it winds up being just negative 1 over x squared. Oh, wait, let me make sure about that. 1 minus... No, I think it's positive 1 over x squared, actually, if you do it out. And so anyway, this point, we get 1/2. So remember I said it was frustrating, never ending? No, it ended. There it is. We're done. Okay. One more type of problem that we can solve with L'Hopital's rule. Okay, now I'm not sure how realistic this is that you would see this, but you might. You might. We have a situation like this where we have an x in the base and an x in the exponent. And I don't know if this form looks familiar at all. If it doesn't, then don't worry about it. But this is a little different. That 5x in the exponent is really messing with us. So we employ a trick, which maybe you've seen before. Maybe you can remember where you've seen something like this. Let it equal y. And then look what we're going to do. Tell me if this sounds familiar. Let me actually move this over here. Let's take the ln of both sides. Does that seem familiar? Now, it turns out that because this is a continuous function, that you're allowed to stick ln inside the limit. Okay? And this is nice because now that we have ln on both sides, we can bring down that 5x right in front of the ln. And this is not the nicest thing in the world, but it's a little more manageable, right? At this point, by the way, I should say, why do we have this? Why do we even need to do this? Well, if you just try plugging in infinity, you get 1 to the infinity, which is not a workable indeterminate form. It is an indeterminate form, but it's not like workable, like it's not an answer or anything. At this point, if you try plugging in infinity, you wind up getting infinity times 0. So what does that suggest? Well, maybe we have to do that multiplication, division trick again. Right? Now remember, be careful to leave the 5 up there and the 1 over x on the bottom. That'll be important. So anyway, at this point, we have 0 over 0 indeterminate form. And so at this point, we can use L'Hopital's rule. So we have 5 over 1 plus 6 over x times the derivative of 6 over x, which is negative 6 over x squared. And then this is derivative of 1 over x is negative 1 over x squared. And just note, the negatives cancel and the x squareds cancel. Lovely, right? Because everything is multiplied. And so you wind up getting... excuse me. Right, and we are approaching infinity, right? Yes. You wind up getting 5, well, I'll write this one more time. Limit as x approaches infinity of 5 over 1 plus 6 over x times 6. And this winds up equaling 30. So you might say, okay, well, our answer is 30, really? This equals 30? Not quite. Remember, ln of our answer is 30. So ln of y equals 30. So y equals e to the 30. So our limit as x approaches infinity of 1 plus, was that 6 over x to the 5x, equals e to the 30th. And that's somewhat surprising, but remember, just recall that e to the x was defined to be the limit as x approaches infinity of 1 plus 1 over x to the x. So maybe it's not a shocker that we get this answer in terms of e. And that's all we've got.